Hello everyone, it's a pleasure meeting you in my class. See, this is a problem wherein we are given the random variables xy and also its joint probability density function, namely f of xy is equal to x plus y, which is defined in the interval 0 less than or equal to x less than y and less than or equal to 1, in the sense that both these x and y are defined in the intervals 0 to 1 only, and you are given a transformation like this: u is equal to xy. Now you have to find the probability density function of u. We have to find the probability density function of u. Here I will explain this problem again. This is a problem in which you are given the joint PDF, joint probability density function of two random variables x and y as x plus y, and this probability density function is defined in the interval 0 xy less than 1, in the sense x and y take the values in the interval 0 less than or equal to x less than or equal to 1 and 0 less than or equal to y less than or equal to 1, and that a relation like this given, a function u is equal to xy is given. Now you have to find the probability density function of u. That is, see here given, I'll write here, given fx of y is equal to x plus y, and this is 0 less than or equal to x less than 1, 0 less than or equal to 1, and u is equal to xy. To find f of u, the probability density function of u. So this is the problem. So you are given this in this interval, and your xy is the random variable. Now u is equal to xy is given. Now you see that this xy is defined like this. It is so you see that this xy random variable is defined only, it is taking values only in this region, and your probability density function is taking values here. Now you see that we have to understand that in this region this is the probability density function, and hence the double integral of this over 0 to 1 and 0 to 1 is 1. Okay, now keep that in your mind. Now let us try to find out what is the probability density function, namely u of n, for which let, say I'll write here, let y is equal to v be the auxiliary random variable. So it is also a random variable. This is also a random variable. Then we have see what is that you are having here. Then we have u is equal to xy and v is equal to y. v. So we are having a relation like this. So from this, what is that you get here? So you get u is equal to xy and v is equal to y. This implies, here you see that u is equal to x into v, which implies x is equal to u by v. X is equal to u by v. Now, having got this, so we are able to get the value of this. See, what is that you are having now? So your x is u by v and y is equal to v. Now your joint probability density function, namely uv of uv, is given by j, which is nothing but the Jacobian, into fxy of xy, where your j is equal to dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. So this is the value of this. Now, so you can get here, what is that you get here? So I'll write here, see, dou x by dou u, differentiate this with respect to u, 1 by v, and dou x by dou v is equal to minus u by minus v squared, u by minus v squared, because v into differentiation of u is 0 minus u into, see, v into differentiation of u is 0 minus u into differentiation of u, v is 1 divided by this one. So this is minus u by v squared. Dou x by dou y, then we want dou y. Dou y by dou u is 0. Dou y by dou v is equal to 1. So dou x by dou u is 1 by v. Dou x by dou v is minus u by v squared. Dou y by dou v is 0 because this is y is independent of u, and dou y by dou v is equal to 1. Now substitute the values here. Dou x by dou y is 1 by v, and this is minus u by v squared, and this is 1, and you get this to be equal to your 1 by v. So what is that you get here? So j is equal to 1 by v. So this is what you get here. Now you see that, therefore, what is that you get here? F of uv is equal to, it is 1 by v into f of, see, f of x, xu, xy. So you see that this has to be changed. So what is that you get here? So here I will write here. So in this place you have to write what is in the place of x you have got here. X is equal to, you have got here, see, x is equal to u by v, and y is equal to v. So this is what you get here. So this is the value of this is modulus value. So this is equal to, I will put this as u by v squared plus 1. U by v squared plus 1. And you must know, so this f of, what is that I am getting here? F of uv is equal to u by v squared plus 1. Now it must be, this is defined just like this. This must be defined in some interval. And you see that so I will put here, so this is what we have. I will explain things here. So you see that here x is equal to, you have taken y is equal to v. Y is greater, see, y is 0 less than or equal to y less than or equal to 1 implies 0 less than or equal to v less than or equal to 1. Also, see, 0 less than or equal to x less than or, therefore 0 less than or equal to, see, your x is equal to, you just see what is that value of this x, u by v. So u by v is less than or equal to 1. This implies it is throughout multiplied by v. So 0 less than or equal to u less than or equal to v. So you see that here you are given, so this is this probability density function is defined just like this. This must be defined over a region, and this is defined over the region. It is 0, so it is 0 less than or equal to u less than or equal to v, and 0 less than or equal to v less than or equal to 1. So you see that this combined probability density function, joint probability density function of uv is defined in this particular interval. Now that having got this joint PDF, now I can go for calculating the or finding the probability density function of u which is equal to xy. Are you able to understand? So I'll just explain what I have done now. So you see that you are given u is equal to xy, and we have assumed v is equal to y as our auxiliary random variable. So you see that from this I am able to get x is equal to u by v and y is equal to v. Now if I want to get the joint probability density function of uv, then it is equal to 1 by, you see that it is equal to the Jacobian. The Jacobian obtained in this way, that is where Jacobian is equal to dou x by dou u, dou x by dou v, dou y by dou u, and dou y by dou v. This is how we get the Jacobian, and this Jacobian into your probability density function, which must be changed to the random variables x, u and v. Now you see that how do you get this j? I have explained here. Now it is, you see that dou x by dou u has been got, dou x by dou v, which is nothing but u by minus u by v squared, has been got. So substitute these values, and what is the value of the determinant? It is 1 into 1 by v minus 0 into this is 0. Therefore your modulus of j, that is the Jacobian, is 1 by v. Therefore this is equal to your 1 by v. You can write like this. So this is absolute value. It is not negative. It is not negative. So you see that you get the f of u is equal to 1 by v into this, that is u by v squared plus 1 by v, and then as I told you here, this random variable has been defined, or the probability density function is defined in the region given here. Likewise, you must be able to get the region where this random variable is defined, for which I take this. I have assumed y is equal to v, but y is lying between 0 and 1, therefore v also lies between 0 and 1. And we have got the value of x, and x also lies between 0 and 1. But x value is u by v. Therefore 0 less than or equal to u by v less than or equal to 1. Throughout you multiply by v. So v into 0 is 0, less than or equal to u, less than or equal to v. Therefore you see that this joint probability density function is taking values in the region defined by 0 less than or equal to u, less than or equal to v, and 0 less than or equal to v. After all, v is less than or equal to 1. So this u also will be lying between 0 and 1. That is quite very easily understandable. Now having got this, I will try to find the value of this f of, say, what is that I must find? what is this? F of u, that is the probability density function of u. Now I'll write here. So we have got this. I will write everything here. See, so what is that you want now? Now we know that, I'll write here, we know that, see, it is actually speaking, it is marginal density function of u. We know that the marginal density, it is like this, marginal density function of u. This is the meaning of this. U is f of u of u, which is equal to, it is nothing but what? Minus infinity to plus infinity, f of uv into, if it is u, it must be dv. Are you able to understand? Now you see that this is how. So if it is random variable x and y, then the probability density function, marginal density function of x will be, fx of x will be minus infinity plus infinity, f of xy into dy. If you want f of y, then it must be here f of xy into fx, double integral of that. So this is, as I told you in my last class, that this can be taken as a formula like that. This is how you get. And if you want for v, then you must integrate with respect to u. Now let me draw the diagram for this. What is this? See, let us draw the diagram for this, then only I will be able to find out what is the domain in which this integral has to be evaluated. Now what is this now? So this is what, see, 0 less than 0 less than or equal to v less than or equal to 1. That means what? This is your v and this is your v. Let us take this point. So draw this line, v is equal to 0. V is equal to 0 is this line and v is equal to 1 is this line. So you see that this is your v and this is your v is equal to 0. So for this v is equal to 1 means it can be throughout, it can be fully like this. So the whole space between x is equal, v is equal to 0 to v is equal to 0, 1 is this region. So what is this region? This region is v is equal to 0 to v is equal to 1. And if you want to draw this line, so this means that you draw the line u is equal to 0. So your u is equal to 0 is this line. U is equal to 0 line. So this is u is equal to 0 line. And you draw this u is equal to v line. U is equal to v line is what? It is u is equal to 0 means 0, u is equal to 1 means 1. So you see that I'll put it like this, this one, 1, 1. So you see that this will be going like this. So this is u is equal to v line. So this is 1, 1. So you see that this u is equal to v is a line passing through the origin and it goes through 0, 0, 1, 1, 2, 2 and here minus 1, minus 1. So it travels through the full points like this, 1, 1, 2, 2, 3, 3, like that, it travels like that. Now u is, see, we want you draw this line, but you want that region where u is less than v. U is less than or equal to v. That means you have to get hold of, see, that means this u is equal to v is the line. See, understand this, this also goes like this. So you have got two regions like this. So first of all, this region, if you draw this line, u is equal to v, it divides it into two regions. One is a region lying above and another one is lying below. But u is greater than or equal to 0 means it definitely this u greater than or equal to 0, it definitely means that all points are lying to the right of this v axis, and therefore you have to get hold of all the points to the right. But u is equal to v is a line passing through the origin. Now you have to choose as per this u is less than or equal to v. What is that? U is less than or equal to v. It defines a region. Try to understand that u is equal to 0 is a line. U is less than or equal to v is a region. In which region you get all those points in which the point u is either equal to v or less than v. Now where can it happen? It cannot happen here, because you see that here this region cannot be there. You see that because if you take 2 here, you will get it will not satisfy. What I mean is that if you take in this line, in this region, your u is 0 here, u is 0 here, definitely all these points will be what? Less than v, because here you see that it is 1 and u is less than, it is 1, 0, 1, and you see that here this u is less than 1, u is equal to 0, which is less than 1. If you take here u is equal to 0 but v is equal to half, so it is less than v. So you see that this is the region in which you get this particular this is satisfied. This inequation is satisfied only in this region. And so for this this is the region. For this, take this, you have to take this and you shade the full area. But for v, it is 0 to 1. Now you see that when you are going to, I'll explain this again because you must be able to understand. So this 0, u greater than or equal to 0 means all points lying to the right. And u is less than or equal to v means you draw the line u is equal to v and decide to choose whether upper region or lower region. I told you that it is upper region because here you see that all the points, u points will be less than v. Therefore, this is the region. That means this full region it will be going. So here as per this, it is nothing but what? Here you take this O and this y-axis, v-axis, and this line passing through the origin, full length will be your region. So that is what we are having. But when you come to this 0 less than or equal to v less than or equal to 1 means v is equal to 0 here, v is equal to 1 here. So you are going to collect only the points in this region, complete region you are going to collect. So you see that there will be a overlapping of region. Suppose if you shade like this, for this, if you are going to give a different shade, say for example I put it like this. For this I put like this. For this, if you are going to shade like this, you see that there is a overlapping of shade. Can you see this? There is a overlapping of shade where you find that this is the region. So you see that this is the region. There is blue and black, they overshade. Where do they overshade here? So this is the region where they overlap. So in this region only you see that your the joint probability density function is, that is the random variable u and v are defined. So I'll just explain once so that it will be better. So you see that draw this line 0 less than or equal to v less than or equal to 1, v is 0 here, v is equal to 1. So the full shade I have put blue shade here, and when you take this one 0 less than or equal to u less than or equal to v means that is u is greater than 0. U is greater than 0 means shade fully to the right. And if you take u less than or equal to means draw this line, you see that this particular portion is defined. This, can you see this triangular like this, a triangular portion, a open triangle like this? So in this region only this particular region is defined. But this region and this region overlap and in this particular triangle only. In this triangle you see that black shade and white shade overlap, and therefore this is the region in which the random variable u and v are. For this particular f of u v is defined. Therefore, this probability density function f of u v is defined only in this region. So that is how you must understand. Okay then. Now let us come to this. Now what does this say? So we have to find this f of u v here. See, f of that is the marginal density function of u we have to find. Now you have to fix up the limit. That is very, very important. So what is that you are having here? So this is equal to, so f of u is equal to minus infinity to plus infinity, and you are having, it is 1 by v into u by v plus v into dv. This is what you have. Now you tell me, how does this v vary? V is varying. See, vertically you have to go here. See, for that I will just take this. I will shade this. See, you see that I take a strip like this. Now at this point it is v is equal to u. V is equal to, and you draw the strip and it will go and dash at this point where v is equal to 1. So you see that this strip is going to graze over this triangular region, which is the region of this random variable, namely uv, and that if you want to find out the limit of v, then you traverse over this line which is passing through the origin, and wherever you are, v is equal to u, and if you just draw a strip like this, it will go and dash against the line v is equal to 1. So it is like this. Here also it is 0 to here, v is equal to u to 1. V is equal to u to 1. Completely it will trace the full triangle. So the limit of v is equal to u to v is equal to 1. So what is that you get here? So this is nothing but v is equal to u to v is equal to 1, and this is u by v squared plus 1 into dv. This is what you get. So this is equal to, you see that this is nothing but your integral. You can do this. So this is equal to, it is integral of v is equal to u to v is equal to 1 u v to the power of minus 2 plus 1 into dv. So this is equal to what? So this is equal to, separate this into this. So it is u to 1, and it is u v to the power of minus 2 into dv plus integral of this dv. It is again u to 1. So what is that you get here? If you take this minus 2, because u is treated as a constant here, it is because integration is with respect to v. So this is nothing but u minus 2 plus 1. See, x to the power of n, integration is x to the power of n plus 1 divided by n plus 1. So you see that it is u v to the power of minus 1 divided by minus 1, and this is u to 1 plus u, this is v, and it takes the value from what? It is u to 1. U to 1. Now what is that you will get here? Now substitute the values. First substitute 1 in the place of v. So you will get this to be what? U, or you can write this as what? Minus u by v. It is u to 1 plus v, it is u to 1. So I just write this as what? V to the power of minus 1 divided as u by v. So this is what I get. So what is that you will get here now? So this is equal to, so I will straight away write. So this will be equal to what? If you substitute here 1, if you put v is equal to 1, it is minus u. And if you put here v is equal to 1 is minus u minus, then if you put v is equal to u, it is minus 1. See, if you put v is equal to 1, it is minus u minus, I will put it here, I will write this here, I will write it here. So this one, f of u is equal to, I will put it here, this one minus u by v is going from u to 1 plus v, it is going from u to 1. So this is, now if you substitute 1 here, take this minus sign outside. No, for this minus I take outside, so it is u and this is minus 1. For this plus, for this it is 1 minus u. So this is equal to minus u plus 1 plus 1 minus u. So that is equal to 2 minus 2u, that is 2 into 1 minus u. So you see that here when you do the apply the limits, you get for this it is minus u into u minus 1 plus 1 minus u. So you get this to be 2 into 1 minus u. So I am able to get the probability density function for y, that is the modular density function of u, that is f of u is 2 into 1 minus u. Now you must know where this limits of u. So u is lying between what? U lies between, u is taking the values from what? 0 to, so you see that where does this what is the limit of u? Because it takes up to 1 only. So you see that it is 0, see it is 0. See what is the limit of u now? So the limit of u is 0 less than or equal to u less than or equal to 1. Because you see that here this 0 less than or equal to u less than or equal to v, but v is taking the value up to 1. So your limit of this u is 0 less than or equal to u less than or equal to 1. If you want to verify whether this is correct or not, then you just integrate over 0 to 1 and see that this is equal to now. Now you just check integral of 2 into 1 minus u du 0 to 1. How much will you get here? 2 into, so the integral of this is u minus u squared by 2, it is 0 to 1. So this is equal to 0 to, if you apply 1 here, 1 minus, see this is 1, half is half minus, if you apply 0 it is 0. So this is equal to what? 2 into half, that is equal to 1. So you see that our function, this one is very much correct, because this integral over this interval 0 to 1, it is equal to what? 1. Therefore this is a valid probability, marginal probability density function of u. So you see that we are able to get the this one. So this is how we do, and here the important thing is that finding the Jacobian and then fixing the region is very, very important. So that art must be learnt. You must be able to thoroughly understand, then only you can fix the limits for the u and v and also obtain the region. Thank you.